Okay, this is going to be lesson 2 on log and exponential characteristics. We're going to start with some basic things here. Okay, I want to talk about things, all right, that equal 1. Okay. Okay, so let's start with some basic stuff, things that equal 1. All right, these are some properties you sort of have to memorize. Okay, if you ever have the same base, 3 and 3, this would just equal 1. Okay, now someone say, Mr. Evans, you don't have a base here. When you don't see a base, you can go ahead and put a 10 in there. So then that would be 1. Any exponent to the 0 power was 1. And anytime you have natural log of e, that is also 1. So 4 things that equal 1 there, okay? Also, things that equal 0. Okay, things that equal 0. The big thing is, anytime you have, there's more so for logs, to be honest. Anytime you have a 1 in this place, this would be 0. Right, remember base 10, but this result would also be 0. We'll discuss why in a little bit, but that's something you need to know. Okay, let's talk about a couple of properties in here. All right, the first one is, go ahead and write these examples down. Log of 5 plus log of 8 plus log of, that's good actually. Let's go log of 2. 20 plus log of 2, 4, and let's talk about natural log of 8 plus natural log of 9. Okay, so the big thing that you have to understand is that addition turns into multiplication. Okay, and what I mean by that, these are both base 10, base 10. Okay, if they got the same base, 4 plus, instead of, it's not 13, it would be log of 10 with 40. Okay, so you multiply 5 times 8. Okay, this right here would be log, okay, of 2, and I do 20 times 4, which would give me 8. Okay, this is the natural log, same thing applies. Natural log would be 8 times 9, which would be 72. So that's a property you should know. Okay, all right, coincidingly, you have the same thing here. Okay, so what we have is that subtraction turns into division. So these are base 10, okay, that'd be log, all right, 10, 30 divided by 5 would just be 6, okay? This would be log base 4, 28 divided by 2 would be 14, okay? And this would be natural log, okay, of 50 minus, that would be 50 divided by 10, which would be 5, okay? So that's a combination, all right? Another thing that you could have is a combination of multiple things, all right? Let's say I have log 8, 30 plus log 8, 4 minus log 8, 2, okay? Let's say natural log of 40 plus natural log of 6 minus natural log of 2. And let's do some variables. Natural log of x plus natural log of y minus natural log of z, okay? All right, so the rules apply, you work left to right. So first of all, I would have multiplication. So 30 times 4, okay, 30 times 4 would be 120. all right? And then I got this subtraction, so that's gonna be log of 8, okay? 120 divided by 2 would be 60, okay? All right, same thing here with natural log. This would be natural log of 240, because I would do 6 times 40. Then I would do natural log 2 minus, so that would be equally to the natural log of 240 divided by 2, which would be 120. Okay? All right? Variables, nothing changes. That would just be natural log of x times y with the minus z, so the z would go underneath because we would be doing division. So that's how you'd apply it from a letter standpoint. Okay? So, what I would like you guys to do, okay, is simplify, okay, the following problems. Okay, so go ahead and pause your video and go ahead and work on those. Okay, so we know that anytime you have the same number here, that's going to be 1. Anytime we have a 5 and a 1, that would be a 0. Anytime you have that and a 0. We always know that natural log of e is just 1. All right, so plus would turn into multiplication, so 12 times 6 would be 72, natural log of 72. We know that subtraction, this is base 10, so I got log base 10, 18 divided by 3, which would be 6, okay? All right, this one I'm going to do, looks like a crummy 3 there, okay? So I would do multiplication first, so it'd be log of 3 with a 48, minus log of 3 with a 6, then I would do division, log of 3, 8. Okay, so when I have letters, I just can write it as a single log. These are all base 10. Okay, so I got z times y, and then divide the whole thing by x. Okay, and I know anything to the 0 power would be 1. Okay, all right, the next thing I'd like to talk about is exponents, and how exponents work. Okay, I want to talk about exponents. Okay, and I think that's good. All right, so go ahead and copy. Whoops. Go ahead and copy those down. Okay. One big property that you know, I got to put something else on here. Let's do. Let's do 3, 9. Let's do 2, So a couple things as far as exponents go, all right? What you want to look at is the property is that these exponents can move down in front. So sometimes there's a convenience of being able to move that in front. Sometimes you can move these back, okay? And I'll show you why you'd want to do that, all right, from that standpoint. The other thing, and probably more importantly you can do, it can help with the simplification process, is stuff when you have radicals, okay? Now, radicals can be written as exponents. Square root can be written as 1/2. Cube root could be written as 1/3. Fourth root could be written as 1/4, okay? So what this would be is log x to the 1/2, and you can move the 1/2 in front of the log, okay? All right, same thing here. This would be natural log of e to the 1/3. If I move that in front, natural log of e, well, what do we know about that? We know the natural log of e is just 1, so that'd be 1/3, okay? Now, here's where you can use this to actually bring it back and simplify. So I bring this 3 up here, so that'd be log 2 to the 3rd, okay? All right, now what is 2 to the 3rd power? That would be just log 8. And these are all base 10. Okay, and now I'm doing a problem like I did before. I can do multiplication, so that'd be log of 10, 48, minus log of 10, 12. Now I'm doing division. 48 divided by that would be 4. Okay, so there's some simplification. The other thing I want to talk about is rewriting bases with exponents. All right, oftentimes if you see a commonality here, is that I can rewrite 3 as a different base. What do I mean? Okay, well, 9 is just 3 squared, okay? So what that allows me to do is move the 2 down in front, and then I know that anything in that would be 1, so it would be 2 times 1. So the answer here would just be 2, okay? The same thing here. I can rewrite this. Someone would say, Mr. Evans, I don't know about 1/8. Well, if I did 8, 2 to the 3rd power is 8. So when you see the fraction, I can just write that as 2 to the -3 power. So what does that allow me to do? Move that -3 down in front. We know that that is 1. -3 times 1 would be -3. Okay, so that's another little property, okay, that you can use. All right, very common, all right, to see that when you have, different bases, or if they want you to write it as something that, to simplify, okay? So what I'd like you guys to do is I'd like you to try to simplify these. All right, so let me give you a couple of these. Let's say log to the x cube root. Let's say natural log square root of e. Let's say go through my questions here I want to practice. Let's say 4 natural log of 3 plus 2 natural log of okay, let's do that one. Let me clean this up a little bit. I like this problem. 3 natural log of 2 plus 4 natural log. So the natural log of 2 of 16. Let's do log base 5 of 1 over 1. And I think that's it. Okay, so go ahead and pause your video and go ahead and work on those. Okay, so the way this would simplify, this would be log, if you want to do base 10, that's fine. X to the 1/3, 1/3 would move down in front. That's all you can do there. Okay, this would be natural log of e to the 1/2. The 1/2 would move down in front. We know that natural log of e is 1. 1/2 times 1 is 1/2. Okay, this one, what I want to do is move that up. So it'd be natural log of 2 to the 3rd plus natural log of 5 minus natural log of 4. Well, 2 to the 3rd is 8. Okay, natural log of 5 minus natural log of 4. Okay, so I do multiplication first, so that'd be natural log of 40 minus natural log of 4, and then divide those, natural log of 10. Okay, this one, all right, I should think of what could I do to what power? Well, that could be written as log base 2, 2 to the 4th power. Okay, so we know that the 4 comes down. We know that that is going to be 1, so it's going to be the answer of 4. Okay, this would be 5. Okay, that looks familiar. So 125 would be 5 to the 3rd, so 5 to the -3. Okay, the -3 would come down in front, so I got negative log 5 to the 5, which is 1, which gives me -3. So a couple of ways that you can simplify, all right, exponents. Okay, what I want to finish this lesson doing is doing some simple converting to the inverse function. Okay, so let's go log base 3 of x equals y. Let's do natural log of x equals y plus 1. Let's do log of a equals b. Let's do 2 to the x equaling y. Let's do this one here. Let's do e to the on the side, e to the x and y. And I think that's good. All right, we're not going to overcomplicate this. Okay. All right. So the basic concept of the inverse function is regular logs are inverses of like exponentials. Okay. The natural logs are inverse of e. Okay. So the first thing you want to do when you do this process is convert to the exponential function. Okay. You want to keep the base in the same spot. Okay? All right, so what I would do, I know this is going to convert to the base of 3, so I want to keep that base. So that's going to convert to 3. All right, I'm going to keep that on the same side of the equal sign. What you do is you move remaining stuff to opposite sides. But you're going to keep the sign. Keep signs. Okay? So the idea is, if y is on this side of the equal sign, it's now going to become the exponent, and then x will come over here, and that's how you do a simple conversion. Okay? Now, this right here would just be e. Okay? So, all right, the y plus 1 would come up here, and then this part right here would go there. Okay? So the stuff just switches. Okay? All right? This, so we say, Mr. Evans, there's no base here. Yeah, there is. There's a 10. So what that would convert to is 10 as an exponential. The a would be over here, and now the b would be in the exponent part. Okay? This one here, I would convert that to a log. Log of base 2. Okay? The y would be here now, and the x would go over on this side. Okay? Now this one is going to convert to natural log, so natural log. Okay? The y goes here, and the x goes here. Okay? All right, so some very simple conversions. Okay? So I'd like to give you some of those to try. Okay? Convert to the inverse function. All right, let's go log 5yx. Let's go natural log of x equaling y. Let's go to log of y equaling x. Let's go to 8 to x plus 1 equaling y. And then let's talk about number 5, e to the 5x equaling y. Okay, so go ahead and see if you can do those problems. Okay, go ahead and unpause your video. So what this would be is this is going to convert to a base here. So these are going to flip, so y is over here, this x has to become the exponent. Okay, this one's going to become e, okay? This y has to come over here and become the exponent, that's going to be the x there. This would be base 10, so it'd be 10. The y is going to come over, the x has to be the exponent. Okay, this is going to convert to log of base 8. Okay, the y's got to come over here, and then the x plus 1's got to come over there. Okay, this is going to convert to natural log. The y would come next to natural log because it doesn't have an exponent, and the 5 with the x would go over there. Okay, so that is our lesson on some of the function characteristics. Next, we'll focus on the equations.